Hi, today in Linux we're going to look at regular expressions, which offer a really powerful way of finding patterns inside data. And today it's so significant because there's so much data that's captured and kept in files, and we need to look through them to find patterns. The program on Linux that does that is Grep. There's also extended grep, which was developed later, and with extended grep, you can do more. So more ways that patterns can be found. The simplest way to detect patterns with regular expression is when you know what you're looking for exactly. So in this example, actually let me go to the matrix, the Linux server. I have a bunch of files here. So if I look at my tab file, well, this is a small file. So of course I can just look at it and say, yep, if I'm looking for JSON as the pattern that I want to find, I can simply look at it and say, yep, there's the pattern I'm looking for. But let's look at the syntax here so that we can adapt that for any size of the file. So grep, then what is the pattern I'm looking for, and what's the file name in which I want to look for that. So my file name is tab file, so grep, the command, pattern, inside double quotes, just to be again on the safe side, so that if there was a space here, it'll retain all of that, and the name of the file. So now as you see, what it does is it goes and retrieves every line which will match. In this case there's only one line matching, so it retrieves that one line and puts it out on the screen. If this was a really big file, so if you look over here, I have this file called words, which has got a lot of the words from the dictionary, plus I've edited that to put a few other things. And as you can see, that's a really large file. So if we were to find a pattern there, we can say grep, and let's say I'm looking for the word hi, and I'm looking for it in the file called words. Look at what happens. It finds so many lines that actually match the pattern I'm looking for. So many lines. Now what you'll notice is that it doesn't look just for the pattern I'm asking for. So how did I show the pattern? I said grep and then hi and the name of the file. So it looks for the pattern anywhere on the line. So even if it's a part of a bigger word, the way I've described my regular expression here, it's going to look for it anywhere anywhere on the line. So it starts to go from left to right and keeps going till it finds that pattern. And if it doesn't find it, it simply goes to the next line and keeps checking. Because there's so many lines, we already know of some concepts that can be useful here. For example, you already learned about piping, so I can pipe or send the output from this command into the next command. And you already know about WC, which is word count. And if I use WC with -L, it'll actually give me how many lines are matching. So this can be useful here because it's telling me that 348 lines have the word hi embedded somewhere on the line. What if the word was either uppercase, lowercase, or mixture? Then you don't want to have a problem if some of the words have an uppercase letter, because as you know, Linux is case sensitive. So to avoid that kind of a problem, I can use -I. Think of that as ignore, and it's asking Linux to ignore uppercase or lowercase. And in this case, if you notice, the number of lines now is more. So we found 348 lines before, now we found 375 lines. That means we were initially missing some lines because they happen to have uppercase as opposed to all lowercase. So that's always a good thing to remember. -I means ignore uppercase or lowercase. We can also use -C to say count the lines. So then we don't need this here. So -C will give us the same deal. So grep, ignore uppercase, lowercase, count the lines that match. The other thing we can do is use -N for number the line number. So now what it's going to do is, as it shows you the output, it also shows you which line it found it on. So this is on line 473,715. That's where this line occurs, and that's where it's finding the pattern we're looking for. So all of those options are useful. So this is the simplest case where we know the exact pattern we're looking for and we're finding it. But that's not always going to be the case. Many times you'll need to use what's called metacharacters, so other special characters which have a special meaning and get interpreted by the operating system. So let's look at each one of those. So some of the common ones we're going to look at is a dot, square bracket, caret sign, dollar sign, round brackets, forward slash, the backslash, the pipe, asterisk, curly brackets, question mark, and the plus sign. So all of these have a special meaning, and let's look at examples to try and understand that. The very first one here is a dot, and a dot means in regular expressions any one character. So for example, if I was to put 5 dots here inside the double quotes, I'm telling Linux, look for 5 characters on the line. And this can be any character. So it could be ABCD, it could be numbers, it could be special characters, it doesn't matter. As long as it finds at least 5 characters, this is going to be a match. Let's look at some other examples here. So let's say I'm looking for the pattern leaf, and I'm looking for that inside words. Now there's a lot of, again, different lines where LEAF is found. But what if I wanted to say that I want to only look at those lines where leaf has another character after that, and that's what my pattern should be. So not just leaf, but leaf followed by one more character at least. To do that, I can use a dot to say one more character. Now it's not going to find anything that just has leaf and nothing after that, because I'm now mandating one extra character to be present. So if you notice now, it has to have leaf followed by another character. Now again, it doesn't matter what that character is, and it doesn't matter where on the line it occurs, as long as there is one additional character. So that's what this one dot is doing. If I was to put 2 dots here, now it's only going to find LEAF followed by 1 character and 2 characters. If there's more, it doesn't matter, but it can't be less. Can't be less than that. What if instead of a dot, I wanted to say, you know what, after leaf, I just want 1 character, but I don't want it to be any character. I only want if it's an S here, or if it's a Y. So I want S or Y and nothing else. So here, it's looking for everything that has a Y at the after LEAF or an S. So what we've just done here is looked at the second meta character of square brackets, and this is referred to as class. So in this class, anything that we put inside the square bracket becomes the choices for that one character. So the important thing to remember here is one set of square brackets is representing 1 character, not 2. Even though we're putting 2 characters here, those are just 2 choices that can be chosen after this pattern. So it can be LEAFS or it can be LEAFY. Nothing else is going to match. So think of this as a basket with two blocks. One block has S, one block has Y, and we can only pick up 1 block out of those 2 here. All right? If I change this, and if I actually put a dot before that, now what I'm saying is before LEAF, it must have 1 character. So in other words, this is no longer going to qualify, because here LEAF is at the start of the line, right? There's no other character before that. So by putting a dot here, These will still qualify because there's at least one more character before LEAF. More characters is okay, but the minimum would be one, and that's what the dot is saying. So these will no longer show up. See, the ones that begin here, and after we put this, these are no longer qualifying. Only these are qualifying. So that's how the dot works and how the character class works. Now there's some very important things about the character class that make it very interesting. For example, let's say I wanted to find anything that has a number. Anything that has a number inside the words file. So we do have a few lines. So I put a number, so 0 through 9, those are all valid numbers. So as long as it finds, because one set of square brackets is one character, right? So we're only defining the choices in one character. So as long as there's one number somewhere on the line, it's going to get picked up. It doesn't matter where that one number is, but it's going to pick it up. What if we wanted to say, I want everything except a number? So you can negate what you're looking at here. How do you do that? If you put a caret sign inside as the first character inside the square bracket. Caret sign as the first character inside the square bracket. What you're now saying is, it can be anything but not a number. So everything else will qualify, but not anything that has a number. So you can reverse the meaning of your pattern by putting a caret sign inside the square bracket. The other thing square brackets can be used for is, let's say I was looking for a line which has a dot. See what this does? It actually looks for the actual dot. Remember a minute ago we said a dot means any character? Well, the interesting thing that happens is if you put that special character inside a character class or inside a square bracket, it loses its special powers or loses its special meaning. So no longer is it interpreting the dot as any character. Now what we're saying is, please look for one character which happens to be a dot. So as long as there's one dot somewhere on the line, it's going to get picked up. Let me go back to the leaf example we did earlier. So here, for example, what if I wanted to find all the lines where the leaf is the very last thing on the line? In other words, I want to say leaf, end of line. You can do that by specifying a $sign. This is referred to as an anchor. So you're anchoring or tying this pattern to the end of the line. So notice what happens now. Only those are picked up where leaf is the very last thing on the line. And that's because we have a $sign, which is an anchor or a tie-up to the very end of the line. We can do the same thing for the front of the line. So if I wanted to say, I don't want to worry about where it's ending, but I want the line to begin with the word leaf. The anchor to the front of the line is a caret sign, and that's found with the shift key just above the number 6 on your keyboard. So now it says, show me only those lines where there's leaf, but leaf must be at the beginning of the line. Now because we have no anchor over here, what is happening is after leaf, it's free to have whatever it wants. So there's no control over what happens after leaf. As long as LEAF is the pattern at the start of the line, that's all it cares about. What if I wanted to have both those restrictions? So I want to say it should begin with the leaf, so I have a caret here, but I also want to say that I need to end with the leaf, so I put the $sign here. So really what I'm saying is that on that line, I should see start of line, LEAF, end of line. So the only word that should be on that line is leaf. So only one line qualifies now, because in every other case, either there's stuff after leaf or there's stuff before. But if you only look for a specific thing and that's all you want on the line, anchoring it at the front anchoring it at the end will help you there. And that brings you to another interesting concept. What if I did this? What am I saying now? I'm saying look for start of line immediately followed by end of line and nothing in between. So really what it's going to find is the empty lines, if there is any empty lines in that file. So I'm going to hit enter, and it actually brought some empty lines up. So because I can't really see very well how many empty lines it's picked up from the file. Remember we said we can do a -n, and that will show us the line numbers, right? So if I do this, I'm saying look for empty lines and please show me the line numbers where you're finding these empty lines. So when I hit enter now, it shows me line 13, 23, and 28 are the ones which are empty, blank lines. So that's very useful if you want to find out in case there's any empty lines. Maybe you were not expecting them, and maybe it's a bug in the program that you're using, whatever. So that's a good way of being able to do that. Similarly, if you're looking for, let's say, a certain number of characters on the line, so maybe I'm looking for 1, 2, 3, only those lines where there's a 3-letter word and that's all there is on the line, then this will help me find those, and I can leave my line number option here. So now there's a whole bunch of lines where there's only 3-character words, and it tells you which line it's finding that on. And of course I can pipe this through a WC-L to see how many it found. So it found 6,126 such words which were only 3 characters, and there was nothing before that and nothing after that. Next, we're going to look at, so we've looked at the dot, we've looked at the character class, anchor to the start, anchor to the end. So we're going to now look at what's called grouping, which means you're grouping a few characters together. So in this example that I'm showing here in the notes is I'm grouping ISS with the round brackets, which means it's going to look at it as a group instead of looking just at S, it's going to look at ISS. The fact that I have a question mark here is very interesting too, because question mark has a very unique purpose. And a question mark, which I was going to cover, I guess, a little bit later, but let me talk about it now. A question mark is another special character, and what it does is it says 0 or 1 occurrence of the previous character or character class. So that's really, really interesting because it allows you to make the character that's before the question mark optional. What does that mean? Well, it means, for example, if I was looking for electronics, but I put a question mark here, what is the question mark going to act upon? Upon the character that is just before that. In this case, it's acting upon the letter S. And because it's acting upon the letter S, it's going to allow for either 0 or 1 occurrence of S, which means electronic would be okay because that's 0 occurrence of S, or 1 occurrence would be okay. So electronic will qualify as well as electronics would qualify. So the important thing about question mark is it's not acting on its own. It is acting on the letter or the digit or any character that's immediately before that. And it's making it optional. So if it's there, it's okay. And if it's not there, it's okay. It'll be a match. Let's look at this example. Color. So what is happening here is we have COLOUR, which is one way of spelling it, and the more European way of spelling it, and is also COLOR. Sometimes if you have data from around the globe, sometimes it'll be spelt as color in North American spelling and color with a U in European and some other countries. So if I want to be able to catch both, I can put a question mark just after the U. And what that does is it'll act upon the U and make it optional, which means color will qualify with a U and color will qualify without a U. See how interesting that is? So if we go back to the Mississauga example that we had here for the grouping, look how I've grouped ISS, and the question mark will now act upon not just to S, it'll act upon ISS because it's a group. And it will make the whole group optional, which means Mississauga will qualify because it's looking for ISS, which it finds right here, ISS. And then after that, it's looking for A and U, so this will qualify. Whereas here, SAUGA will qualify because AU matches, AU matches here. And before that, if ISS is not there, it's okay. So both Saga and Mississauga will end up qualifying. If we go here, so you can see that in action. I've got ISS question mark, which will make it optional. So this qualifies as well as this qualifies, all of these. It's very, very interesting behavior with the question mark. The next meta character is alternation. So you can give two choices or more than two choices this way. So you can say, look for either this or this. Here we're saying look for either 1 or 2 or 3, and then look for A after that. And here it's saying look for Mr. Smith, Mr. or Mrs. So one or the other followed by Smith. So again, it gives you multiple choices. So in this case, this is allowing you choice of 1, 2, 3, 4, or 5. And in this one character position, because one grouping is reflecting with the alternation, it's only talking about either this or this or this or this and or this, followed by a capital A. Similarly, we can have either Mr. or Mrs. space and the word Smith, and it catches both Mr. Smith and Mrs. Smith. And the regular expressions continue with some other meta characters, and let's look at some of those. The escape character. Now, if you do not want something to be interpreted as a meta character, you can put one backslash, which is acting as the escape character, and anything after that, one character or one character class following the backslash will not be interpreted. So what this is saying is look for a dot. Don't interpret it, just look for a dot. This is saying look for a question mark. This is saying look for any one of these as a literal, because the moment you put it inside a square bracket, it loses its meaning. So don't forget that part. So let's look at this in action. So if I said egrep and I'm looking for a dot inside the words file, it's going to find all of these. So remember, this is actually exactly the same if we did this, right? Because the moment we put it inside the square bracket, also it loses its meaning. But the difference is, so we get the same answer. The difference is here it will only act upon this one character. So if I wanted to look for 2 dots, I would have to go backslash dot, again backslash dot. If I'm looking for a dash, maybe I'm looking for 2 dashes, so I'm going to have to do backslash and a dash, backslash and a dash, because this will say look for a dash. This will again say look for a dash. And now if there is any line with 2 dashes, that's what's going to come up, at least 2 dashes. All right. The other meta characters that we're going to look at is, we already looked at question marks, so let's look at curly brackets. The curly brackets can be used to say how many times we want to repeat the previous character or character class. And it also allows you to give minimum and maximum. So for example, here we're saying repeat this character class 4 times. So it looks for a number, but then it allows 1, 2, 3, 4. Actually looks for 4 numbers right one after the other. So any of these are going to all qualify. But if we actually put 2 comma 4, we're saying minimum of 2 numbers and a maximum of 4 numbers is what it's looking for. Here we're saying minimum of 1 and the upper limit is non-existent, so it'll be infinite. Any number of characters can be used there. Let's look at that in action. So we've got egrep, we're looking for a number, and we want a minimum of 4 numbers perhaps. So there's only 2 lines where it finds a minimum of 4 numbers, one next to the other. If I said 3 numbers, then it'll find all of these because this is the minimum. There's no anchor here, right? So it can have other stuff before, it can have other stuff after, but it's looking for a minimum of 3 numbers together. And that's why all of these, even this one has 3 numbers, and even though it's a part of an email address, 3 numbers. So it's going to find, anytime it finds 3 numbers, one next to the other, that's going to be a match. So you have to be careful. If you were not expecting these to be a part of the answer or these to be a part of the answer, you have to modify this to try and make it more tight. The next metacharacter is a star or an asterisk. And here, just like in a plus, you have 1 or more characters. In a star, you have 0 or more characters. So let's look at that in action. So let's say I'm going to look for an A, the letter A. After that, I want any number of characters, and then I need a C. And I'm going to look for this in the file words. So we have a long list. What did we look for? We said find an A, so it finds an A. And then the dot star, the way this functions is the star always functions on the previous character or character class, and it makes it optional or allows multiple characters. So in other words, if I just had A followed by a C, that would be a match. Or if I have A, for example, here I have A here, none of these is anything, and we were looking for a C here. So A here, C here, and what's in between is any number of characters. So the easiest way to remember dot star is dot star allows the length of that line to be flexible between the specific patterns. So here the pattern is A and the pattern is C, and in between it can be any number of characters because it allows the previous character to be either 0, which means not existent, or allows multiple occurrences, in this case multiple occurrences of any character, because dot is any character. Let's look at another example. So what's happening here? Actually, I'm going to take the first few lines here and pipe them through this so we can see what's going on. All right. So let's interpret what's going on here. This I just did so that it doesn't go through the whole file. It's only going to take the first 60 lines of the file called words. And then I'm piping the result into the egrep command, which is using this regular expression. So somewhere on the line it's looking for O followed by F. And that's why O followed by F. However, because they have an asterisk here, what does the asterisk act upon? It acts upon the previous character. In this case, it acts upon the letter F. And it allows for either 0, which means if F does not exist, it's okay. It'll still match. Or if it does exist, it allows multiple Fs to be here. And that's why OFF is qualifying. Here, O followed, even though there's no F, it still qualifies because this makes the previous character optional because it allows 0 characters, or multiple F's in this case, multiple characters. Then we have a star before which there's a dot. So this will make the length flexible. In other words, it's going to allow 0 or multiple characters of any type, any number of them and any type of them. And then it looks for ICE. That's why ICE is here, O is here, no F, but that's okay because of this asterisk. And then the space is taken care of because this allows any number of any characters to be present. And that's why on ice will also qualify as a match, as you see here. Off ice also qualifies because OF matches this, and then multiple number of any characters, so you have an extra F and you have a space, and then ice. And here we've got OFF, ICE. So all of these are qualifying. Let's look at another example. So here again, it's looking anywhere on the line. It's going to keep going till it finds a CART. But why is this matching even though there's no T? Because the asterisk acts upon the previous character, which in this case is a T, and allows it to be either non-existent because it's 0 characters or multiple occurrences of it. So in this case, it matches the 0 character. CAR matches, but T has been made optional with the asterisk. And then after that, it doesn't matter. So either car or cart, even if there was an extra T here, that would still qualify because it's going to allow multiple T's here. Let's look at another example. Again here, the asterisk is going to act upon the P and make that optional or multiple occurrences. So in this case, A and P is non-existent because it's okay as it was made optional by this first asterisk. And then it's looking for LE. It finds LE. That's why this is qualifying. Here you've got A and P matching A and P, and this allows multiple occurrences of P. So you have another P here that's allowed, and then you have LE. Why is this one qualifying? Because A matches, P has been made optional by the asterisk, so it's not existing here, which is okay. And then it's looking for L and E. So that's why all of these are qualifying. The most common way you're going to see this being used is dot star. So between a certain set of pattern and another pattern, you don't know what the length of the line is, so dot star will make that flexible and allow that pattern to be here or here and any number of characters in between. That'll be the most common way that you'll see that. All right, so the final, well, there's a couple of things still. So I'm going to give you some examples. For example, let's say we're looking for floating point numbers. Let's build an expression for that. So we're going to do egrep. The floating point number, let's say we're allowing it to have a plus or a minus in front. So by using character class, we can give the option of a plus or a minus, right? So it'll allow either a plus or a minus. But then not all numbers are going to have a sign, so maybe we want to make it optional by putting a question mark, because the question mark acts upon the previous character or character class and makes it optional. After the sign, we have something, let's say minus 200. So minus is taken care of here, and then we want to allow at least one number. So 0 to 9 is the option in this character class. So this will allow at least one number. And we want to allow either one or many numbers. So I'm going to put a plus here because the plus will act upon this and it'll make sure there's at least one number. And then it also allows multiple numbers here. Now we need to account for a dot. And we can either do that by putting it inside a square bracket, or having an escape character. So let's just go backslash, which represents an escape character, and a dot. So this is going to say, do not interpret the character right in front. So the dot will not be interpreted as any character. The dot will be looked at as a dot, because you want, in floating point numbers, you want to look for the dot. Following that, we want one number at least that's allowed, and then it could be two numbers, etc. So we want to allow for all of those. So with this in mind, if we look at the words file, two of these numbers are qualifying because it's saying the plus or minus is allowed. But why is this qualifying? Because we made that sign optional. And then it has at least one number. More than one is okay, because the plus allows for multiple. It has a dot, and then it has a requirement for at least one number, and more than one is okay. So plus will allow multiple numbers here. So we could have many numbers after the dot. That would also be okay. Let's look at another example. I'm just going to show you my, the tab file. Actually, let's look at the comma file, which is a comma delimited file. So let's say in this we are looking at the first name of the person. So we want to cut using our knowledge of the cut command that we have. So we're specifying the delimiter, specifying the field as being the first one inside the comma file. So if we did this, what we would end up with is just the first names. Maybe we were looking for the first name that begins with the letter A. So we can pipe this and say, look for, so egrep, and the pattern I want is at the beginning of the line, so I'm going to put an anchor, so I want an A. So now I'm only going to get this one. What's happening here is it's taking the output, which was going to be just the names, and then it's going to feed that into the next command, which is your egrep command. So it's going to look at A being the first character in whatever it's being fed. In this case, the names that are being fed is what it is looking at. And the last example I'm going to give you is if you're looking for emails, so email addresses inside a file. So I'm going to egrep. We can look at dot star, so any number of any characters, just to make it simple. But then we want an @ sign somewhere. Following that, we're going to have again dot star, any number of characters. But then we also, for example, if it's gmail.com, you need to look for a dot. So we're going to look for a dot by putting the escape character. And then after that, we can have .edu, .com, .net, or .ca. So we want to allow for a lowercase or uppercase, it doesn't matter, a letter. But along with that, we also want to say that this can only be either 2 characters or 3 character repetition that we want, because we only want something like, say, .ca, which means 2 characters, or .com, which is 3 characters. We don't want too many more combinations. So I forgot to put the closing and also the word file. Alright, so it picked up these 3 different email addresses based on this regular expression. So you can see how we can kind of build the regular expression based on the type of pattern we're looking for. And the last item in this video is going to be that we can use VI editor and use regular expressions there as well. So that was going to be my last example. So if I'm going to go into, let's say, my tab file, just so that it's a small version, not a very large file. Alright, so if this is my existing file, let's see how we can use regular expressions here. So to do that, we have to come all the way down to the bottom of the screen. So escape : so we come down to the bottom of the screen. Now here is where you put the regular expression. So let's say we want to say that in the third line, so we put the number 3, we want to substitute, so that's an S. What are we substituting? The existing pattern is the letter A, lowercase, and I want to make it uppercase. So if you look at how this is structured, it becomes really easy to remember or understand it. So the first thing is the line number. So it's going to go on the third line. S is saying I want to substitute. The pattern you put here will be the existing pattern, so it's going to look for lowercase a and it'll find it here, and it'll find it here. And we are going to ask it to replace it with uppercase A. So if we do this, it actually goes and finds the pattern, which is here, and it makes the replacement, but it only does it for that one occurrence. Notice that this never changed. So this is one way of changing a pattern if you're looking at changing the first occurrence of a pattern on a certain line. What if you were looking to change the pattern in more than one lines? So I could say that go in line 2 and 3. So instead of putting one line number, I'm going to put a range of line numbers, in this case 2, 3, to say lines 2 and 3. I'm still substituting the lowercase a with uppercase A. So now it does that in line 2, again the first occurrence, and in line 3, again the first occurrence. What if you want to substitute in the entire document, not in a specific line? Then you do that by putting a percent sign, and then we do the same substitution, existing pattern, new pattern. Now notice that all of the occurrences of A have changed. So %s will do it through the entire file. If you put a line number instead of the percent sign, it'll do it only in that one line or the range of lines. And you can also say that I want to substitute from line number 1 to the current. So any line number, comma, and a dot says from that line to where I am right now. And then you will do your substitution. And the last thing I wanted to show you is you can also say from the current, so dot, which is the current, comma, and then from the current location I want to do in the next 2 lines, substitute lowercase a with uppercase A. And of course, based on my current position of the cursor, it didn't find that pattern. But those are the ways in which in the VI editor we can use regular expressions, and if it's a large file, then it can handle the changes or substitutions by using regular expressions. So those are some of the ways in which we are using regular expressions. We will be doing scripting soon, in which regular expressions will also be used significantly whenever we're dealing with text files to find patterns and so on. And that's it for this video for regular expressions. Take care.